Have you ever stopped and wondered how a machine goes from just, crunching numbers to creating incredible art, writing poetry, or even outsmarting the best chess grandmasters on the planet? I mean, how did we go from basic, simple commands to the mind-blowing AI we're all talking about today? Well, let's unpack how AI actually learned to think.
But before we dive in, let's play a quick game. I want to see just how good this tech has gotten and maybe test your instincts a little bit. I'm going to show you a few things, and all you have to do is tell me which one was made by a machine. You ready? Let's do it.
All right, first up, here are two portraits. One of these is a real person, and the other one was dreamed up pixel by pixel by an AI. So, which one is the fake? Is it the face on the left or the one on the right? Go on, take a close look.
If you guessed the face on the right, you got it. You're absolutely correct. And you're not alone. In the original experiment, over 70% of people also picked that one. There's just something about it that looks a little too perfect, But hey, don't get too comfortable just yet. Okay, let's go for round two. Same deal, different faces. Which one of these people is not real? Take a look. Is it the person on the left or the one on the right? This one might be a little trickier.
Yeah, that was a trick question. The answer is both of them. Neither of these people actually exist, and that's exactly the point. This technology is moving so unbelievably fast that telling what's real from what's not is becoming almost impossible.
Okay, one last test. This time, we're moving from faces to words. Here are two short essays, supposedly written by a fourth grader. Your job, figure out which one came from a chatbot.
Essay number 1 was the AI. And you know what the giveaway was? The phrase, catch up on each other's day. It just sounds a little too polished, a little too grown up for a 9-year-old, right? It's these tiny, subtle patterns that give the machine away. So how on earth did AI get this smart? Well, believe it or not, it all started with some very, very simple rules. You see, the very first AIs weren't really learning anything at all. They were just ridiculously fast at following a strict list of instructions that we humans wrote for them. You can think of it as a giant rule book of if this happens, then you do that.
This whole idea is based on something called a decision tree. It's basically a big flowchart of simple yes or no questions that guides the AI to the right action. And it's actually the perfect way to teach a computer how to play a simple game. Say like the old school arcade classic Breakout.
For an AI playing Breakout, the logic is dead simple. Is the ball to my left? Okay, move left. Is the ball to my right? Move right. If neither is true, don't move. By just following those 3 little rules, the AI can play a perfect game every single time. But what happens when the game needs a real strategy?
Right, because for games like Tic-Tac-Toe, or especially chess, just reacting to the moment isn't going to cut it. The AI has to think moves ahead. It has to predict what its opponent is going to do and then plan its own moves accordingly.
This is where a clever little algorithm called minimax comes into play. The idea is basically to turn the game into a math problem. We just give a score to every possible outcome, +1 for a win, -1 for a loss, and 0 for a tie. The AI's only goal is to make moves that maximize its own score, and it does this by assuming its opponent is always trying to minimize that score.
Now for tic-tac-toe, this works perfectly, but for a game like chess, well, it falls apart, and it falls apart fast. Just look at this number. There are 85 times billion different ways to play just the first 4 moves. A simple decision tree would be unimaginably huge. A computer just can't calculate every single possibility, so we needed a whole new way of thinking.
So what if, instead of handing the AI a rule book, we just let it figure things out on its own? This is the big idea behind something called reinforcement learning. The AI learns from the consequences of its actions, kind of like how you teach a dog a new trick with treats.
Imagine an AI that's just been dropped into this maze. Every time it hits a red wall, a dead end, it gets a little digital punishment. But every move that brings it closer to that green exit earns it a reward. After trying and failing thousands, even millions of times, it starts to build a map in its head, learning the paths that lead to success, and eventually finding the absolute best way to solve the maze.
And this creates this really cool dilemma for the AI. Should it exploit the path it already knows works, even if it's kind of long, or should it explore brand new random paths? Now that's risky, it might fail, but it could also lead to finding a much, much faster route. And the best AIs, they learn how to balance both. And this is what happens when you just let an AI explore. After hundreds of training sessions playing Breakout, the AI found a strategy that no human ever told it to look for. It figured out how to tunnel the ball through the top row of bricks, letting it just bounce around up there, clearing the whole board all by itself. I mean, it didn't just learn the rules, it found a way to completely break the game.
That moment with the breakout AI was a huge breakthrough. It showed us that an AI could come up with strategies we'd never even dreamed of. And that led to the next big question. What if, instead of teaching an AI a bunch of rules, we could build it something like a brain and just let it learn? And that brings us to the real cutting edge: neural networks and large language models.
Okay, so a neural network is a computer system made up of all these interconnected digital neurons. Now, it's not actually thinking like we do, but it is incredibly good at one specific thing: recognizing patterns. By sifting through millions and millions of examples, pictures, sounds, text, it learns how to make connections and, well, make predictions. So the AI behind things like ChatGPT are called large language models, or LLMs for short. And what they are is just massive neural networks that have been trained on basically the entire internet. But at their very core, they're constantly trying to answer one very simple question: what is the most probable next word? So if you type in a phrase like, "the Massachusetts state's capital is," the model has seen billions of sentences where that exact phrase is followed by the word Boston. So it predicts Boston. It's not thinking or understanding geography, it's just pattern recognition and probability on a scale that is almost impossible to imagine. Which brings us right up to today. Probably the best way to think about modern AI isn't as some kind of artificial human. It's more like an amazing co-pilot, a tool that can seriously amplify our own intelligence and creativity, helping us get past the boring stuff so we can focus on the big picture.
But, and this is a big but, there's a catch. Sometimes these models just get things wrong. They hallucinate. They literally make stuff up. And this was captured perfectly decades ago in a Shel Silverstein poem about a homework machine that just confidently spat out that 9 plus 4 is 3. It's funny, but it's also a really important reminder to never ever blindly trust what the machine tells you.
And that leaves us with one final and, I think, really crucial question. As these incredible tools get woven deeper and deeper into our daily lives, how do we make sure we're using them to make ourselves smarter and more creative without letting them become a crutch that just replaces our own ability to think and to understand? That, right there, is the challenge for all of us to figure out.